Hello friends, in Industrial Instrumentation lecture series, today we will see about measurement of flow using Pitot tube. So first of all, let us see what is Pitot tube. A Pitot tube, also known as a Pitot probe, it is a flow measurement device used to measure fluid flow velocity. The Pitot tube has invented by the French engineer Henri Pitot in the early 18th century, and it was modified to its modern form in the mid 19th century by French scientist Henri Darcy. It works on the principle of converting kinetic energy of the fluid being metered into a static head. Pitot tubes are essentially a laboratory type of instrument, are not normally used for industrial applications. Here there is a construction of Pitot tube. In this we want to measure the flow of a liquid. Here Pitot tube is inserted between the nozzle, and here we can see that there is two tubes in Pitot tube. One is inner tube and another one is outer tube. There is some hole on outer tube, and inclined tube manometer is also connected here, and with the help of differential pressure we can measure the flow. As shown in the figure, Pitot tube installed in a pipeline for a measurement of flow rate. The Pitot tube consists of two tubes, as we will see earlier, inner and outer tube. The open end of the inner tube faces the incoming flow, and the outer tube has a closed end but has a number of holes in its walls. Now let us see some of the working of Pitot tube. Number of devices for sensing the rate of fluid flow. They mainly operate on the principle of placing an obstruction in the path of fluid, causing a change in fluid pressure which is dependent upon the rate of flow. Here both the tube contain same fluid. The pressure in the outer tube is the static pressure in the pipeline. The total pressure in the inner tube is greater than this static pressure. So we can say that the Bernoulli's theorem shows that the velocity at this point in the cross section is V is equal to under root 2 in bracket P minus P0 whole divided by rho, where P0 is equal to static pressure in Newton per meter square, P is equal to pressure at the entrance of the tube, and rho, that is density of liquid in kilogram per meter cube. Thus, the velocity at a particular point may be determined from the pressure differential generated by the Pitot tube, which is measured by an inclined tube manometer, as we will connect it as shown in figure. The velocity of a fluid across a section of pipe is not uniform but varies from 0 at the pipe surface to a maximum, usually at the center of the pipe. In order to find a mean velocity, it is necessary to make a traverse of the pipe. Now let us see some of the advantages of Pitot tube. They produce a negligible loss of head when inserted in the pipe. Their cost is much smaller than that of venturi meters or orifice meters. Do not contain moving parts, so we can say that this minimizes the frictional losses. Easy to install. Due to its small size, it can introduce to fluid flow without shutting down the flow. Now let us see some of the disadvantages of Pitot tube. They are laboratory type instruments, low sensitivity, poor accuracy, it requires high velocity flow, not suitable for dirty or sticky fluid like sewage disposal. There is no standardization for Pitot tube. A change in velocity profile may cause significant error. Due to change in velocity profile, it develops a very low differential pressure which is difficult to measure. Now let us see some of the application of Pitot tube. The Pitot tube is used in utility streams where high accuracy is not necessary. It is used in the air duct and pipe system. It is used in aircraft to measure airflow velocity. They are used for mapping flow profile in a channel or